Hello everybody. In this lesson we're going to learn how to solve graphing inequalities by two different methods, both graphing and algebraically. So you're going to need some graph paper for today's lesson, so go ahead and take out some graph paper and let's do example A together. Just like we did in the previous section, we're going to graph the left side and the right side of the inequality individually. So the left side we're going to graph as y1, and the right side we're going to graph as y2. The left side is an absolute value graph that has been shifted 3 units to the left and up 1 unit. So a normal absolute value graph would look like this. So we're going to shift that graph left 3 and up 1. So this, what was at the origin, is going to be here at -3, 1. And so our graph is going to look like this. And now the right side of the equation I'll graph in red. That's y equals 4. So y equals 4 would look like this. And we want to know, where is the left equation, the blue graph, where is it greater than the red graph? And so that we're looking for the part of the blue graph that is above the red graph, and so that is this part of the graph, and this part of the graph is where the blue graph is higher than the red graph. And so if we translate those yellow marks down to the x-axis, it's these x values. And these x values. So basically I just took that yellow graph and looked at its shadow down on the x-axis. And so that corresponds to these solutions on the x-axis. So from 0, everything to the right, and -1, 2, 3, 4, 5, 6, -6, and everything to the left. So for our solution, we see the solution graphed on the number line, that we can also say that's when x is greater than 0 and when x is less than -6. In example B, we'll do the same thing. We'll graph the left side and the right side independently. So the graph of y1 equals negative absolute value of x plus 2 would be an absolute value graph. The negative sign flips it upside down, and then we're going to shift it up 2. And the right side is y2 equals 5. That's here. And we want to know, where is the blue graph below or equal to the red graph? and the blue graph is below the red graph everywhere. And so if we were to highlight it like we did in example A, that would be the entire blue graph is below the entire red graph everywhere. And so we'd say that this is a true inequality for all x values. If I translate the highlighted area onto the x-axis, it would be the entire x-axis that gets shaded. And so if we did our number line graph, the entire number line would be shaded. And so we'll say x can be any real number. Or in other words, x can be anything in between negative infinity and infinity. So I'd like you to try example C now. Go ahead and pause your video. Try example C by graphing the left side and the right side individually, and then press play when you're ready to see the solution. So the left side is an absolute value graph shifted left 1 and down 4. And then if we graph the right side of the equation in red, y equals -2. Now we want to know where the left graph, it says, is greater than or equal to the red graph. So we're looking for where is the blue graph higher than the red graph, and that happens here and here. And then if we translate those solutions onto the x-axis, that would look like this. And this. And so our number line graph goes from 1 to infinity, including 1, because it says greater than or equal to. So we'd have this part of the number line shaded, and this part of the number line shaded. And that's at -3. So the solutions are when x is greater than or equal to 1, and when x is less than or equal to -3. Now we'll see how to solve absolute value inequalities algebraically. And so it says here, solve each equation algebraically by testing regions of the number line. Okay, so we'll start off by isolating the absolute value part of the equation, and we're going to change this to an equal sign temporarily. So absolute value of x minus 2 is greater than 2. That's when we subtract 1 from both sides. And again, we'll change that to an equal sign. And then now we have the absolute value part by itself. We can break that into two different equations. We say the inside of the absolute value could be 2, or the inside of the absolute value could be -2. And so then if I solve this one, I get x equals 4. If I solve this one, I get x equals 0. And so that breaks the number line up into, if we mark those numbers 0 and 4, then we have 3 different regions of the number line. And so we're going to try numbers in each of those three regions and see which ones work and mark the number line region as yes or no. So if I pick a number down here, that would be something like -2. If I plug that into the original inequality, I'm going to plug in -2. So -2 minus 2, take the absolute value of that, add 1, is that greater than 3? And so this is the absolute value of -4, which is 4. So we have 4 plus 1. Is that greater than 3? Yes, 5 is greater than 3. So that's a yes. And so this is a yes region of the graph. Okay, now we're going to try a number in here. So a number in between 0 and 4. Let's try 1. If we plug in 1 for x, 1 minus 2, absolute value of 1 minus 2 plus 1, is that greater than 3? This is going to be the absolute value of -1. So absolute value of -1 is +1. 1 plus 1 is 2. Is 2 greater than 3? And that is no, that's not true. So this is a no region. And then if we try a number, anything up here bigger than 4, we could try 5, for example. Absolute value of 5 minus 2 plus 1, is that bigger than 3? And so this is going to be 3 plus 1 is bigger than 3. 4 is bigger than 3, and yes, that's true. So this is a yes region. And since this is a strict inequality, greater than, we're going to take the yes regions but not include the endpoints, because it doesn't say greater than or equal to, it just says greater than. And so we shade in our yes regions. So there's our solution regions. And so we say x can be anything less than 0, and x can be anything greater than 4. On example B, to get the absolute value part by itself, again, we're going to change this to an equal sign, and I'm going to subtract 1 from both sides. So now I have negative absolute value of x is equal to 6. Divide both sides by -1, and we see that x, the absolute value of any number can never be equal to -6. So this doesn't have any solutions. So that means we're going to have the entire number line with only one region, because there are no solutions to this equation. And so that means our solution is either going to be the entire number line or none of the number line. So go ahead and just pick any number you want on the number line and test it. An easy number to plug in is 0. So if I plug in 0 to test it, negative absolute value of 0 plus 1, is that less than 7? 1 is less than 7, and so that's yes. So that means the entire number line is a yes region, and so we would shade the entire number line. And so we say x can be any real number. Or in other words, x can be anything in between -infinity and infinity. Okay, go ahead and pause your video and try example C on your own, solving it algebraically. To get the absolute value part by itself, I need to add 2 to both sides. Now I have the absolute value of x plus 3 is equal to 3. We can break that into two different equations. The inside of the absolute value is equal to 3. or the inside of the absolute value is equal to -3. Subtract 3 from both sides, and I get x equals 0. Subtract 3 from both sides, I get x equals -6. So now we mark those solutions on the number line. -6 and 0. Now we have 3 different regions to test. If I test our number here, that would be something like -7. So if I test that in the original, go back to the original inequality, absolute value of -7 plus 3 minus 2, is that less than or equal to 1? This is the absolute value of -4. Four minus 2, and we get 2 is 2 less than or equal to 1, and that is no. So that's a no region. If I plug in a number here, like -1, is the absolute value of -1 plus 3 minus 2, is that less than or equal to 1? So we have 2 minus 2, is that less than or equal to 1? 0 is less than or equal to 1, so that's a yes region. Okay, and now we can try a number in the last region. That would be a number like 2, for example. Is the absolute value of 2 plus 3 minus 2 less than or equal to 1? We get 5 minus 2, is that less than or equal to 1? And 3 is not less than or equal to 1, that's no. So this is a no region. So our yes region is everything in between -6 and 0. So we get everything here. And so our solution then is x can be anything in between -6 and 0. And that completes our lesson on solving absolute value inequalities. Have a great day.